All right, so what do we do here? This is a linear, one-dimensional, discrete dynamical system. The first step is to identify A and D. So A is 7/8 in this case, and D is 76. The equilibrium value is given, you're actually going to have it memorized as a formula. I don't really remember this formula. I solve for it every time. So what I would do is put a P bar here for both or an X here for both and solve that equation. You're always going to get D divided by 1 minus A as long as A is not 1. So A is not 1, A is 7/8. So I can crank it through this formula and I get 608 up here. Number 6, you're supposed to graph the time series. How do I do that? Well, I just make an XY chart. The X's are my N's, the Y's are my DDS results, the recursion equation results. At n equals 0, they gave you 308. By the way, that reminds me, on the previous problem, they gave you the initial condition. You didn't need to use it. Be careful. Sometimes you get too much information. So here I get 308 for my first. And then my second, if you want to, you can put this into Excel, but my second, and it's pretty easy to do, but my second thing, if I want to do it by hand, is if n equals 1, I get 3 times p sub 0 minus 600. And then p sub 0 is 308, so I get 3 times 308 minus 600. Then I do it again. 3 times 324 minus 600. That turns out to be 372. 3 times 372 minus 600. That turns out to be 516. 3 times 516 minus 600. That turns out to be 948. So I just run this through. And I would recommend putting it on Excel because I make a lot of arithmetic errors. Then you just plot the points. You have a graph where you're going to put the points in a proper position. But I'm doing this by hand, so I'm going to kind of make up where the dots go. I'm just plotting at n equals 0, I get something slightly above 300. At n equals 1, it's a little bit bigger. At n equals 2, I get 372, which is close to 400. And then 3, and see, I made my y-axis in groups of 300 just because I wanted to plot it nicely. And then I get this kind of an upward trend graph.